This is DANL100, Programming for Data Analytics. Chapter 7, Loops and Condition. This is the second video I generate for this chapter, and it's simply related to the application of the loop. Agenda. In this short video, I'll discuss the following topics. Topic number 1, how to use various loops to calculate present value of perpetuity. Topic number 2, how to use various loops to calculate present value of annuity. Topic number 3, how to use loops to calculate NPV, net present value estimation. Topic number 4, how to use loops to calculate IRR estimation. IRR stands for internal rate of return. Topic number 5, how to parse a specific SEC quarterly index file and save it as an R dataset. Then we can use loop to parse all the SEC index files. Topic number 1, we are going to use various loops to calculate present value of perpetuity. First one, we are going to define perpetuity. Type.ice in class exercise. So it's number 15, present value perpetuity. So use up arrow key to recall the previous command. We enter 15. Okay, so this is the definition of perpetuity. Same cash flow as the same interval forever. So we have 3 conditions. Okay, same cash flow at same interval forever. Okay, and here's example number 1. Okay, so this is time 0, 1, 2. So at the end of third period, we have cash flow C. The third period, fourth period, fifth period, then forever. So this is example number 2. At the end of first period, we have C, second period, third period, forever. So this is example number 3. This is general one. So general one will be at end of nth period, we have cash flow C, then n plus 1, C, n plus 2, C, up to infinity. Okay, so we have 3 different types of definition. Okay, example number 3 is general one. Okay. And because we know the present value of perpetuity is simply the present value of all the future cash flow. Okay, so let's look at the general formulas. C divided by 1 plus R, power is K, and the power is K plus 1, and continue this way. K plus 2, K plus 3, continue this way. Okay. Let's look at the special case. Okay, special case is example number 2. The first cash flow at the end of first period. And if we look at the general formula, okay, K equals 1. So K equals 1. Okay. So if this is a case, the first cash flow happens at the end of first period. Then we have this formula. Okay, present value of all the future cash flow equals first cash flow discounted by 1 period, the second cash flow discounted by 2 period, and you see the last for all this infinite present value equals COR. Actually, this is simplest formula. It's COR. I repeat. Okay, we have 3 conditions. The same cash flow at the end of at the same interval forever. So if we plus number 4 condition, number 4 condition is first cash flow happened at the end of first period. Then we have COR. And for this one, so we are going to use different way to do it. Okay, so we can use a for loop and to calculate. Basic idea is we apply this formula. We apply this formula. We use loops. Then we can use while loop. We can use repeat to calculate the present value of. So let's launch a notepad to calculate present value of perpetuity. Is simply a summation of all the present value of future cash flow. Okay, so we need a present value function. We learned in chapter 2. Okay, so this is function. Okay, future value Rn. Okay, future value divided by 1 plus R power is n. Okay, so we are going to repeat this one many times. So let's copy and paste. So let's test it. Okay, the present value function. Suppose we have $100 and 10% on period. Then we get the present value $90.91. Okay. And suppose we said, hey, so let's assume for I in 1, 2, so let's randomly choose 500. And we are going to calculate 500 times. So this is total equals 0. Okay. I can use PV, but the total basic idea is easy to understand. So PV equals the present value function. Okay, so this is future value R, and now its n is I. Okay, I. So this is I. Okay. Total equals total plus present value. Okay. Okay, I'm going to explain the concept here. Okay. So we just assume total equals 0. So total value will be our present value of perpetuity. Okay. You can use PV perpetuity. It's fine. I in 1 to 500. We assume we just randomly choose. We cut off is 500 items. Okay. Then we calculate one present value. Present value. Suppose this should be CRI. Okay. And the total will be total plus the new total equals old total plus present value. Then we stop. Okay. And obviously, so this should be C. Okay. C. Rn. Okay, and C equals 100, R equals 0.1. Okay, and we know we should get 1000. Okay, so this is C over R. I'm going to copy paste, and according to the formula, C over R. So this is our formula. C cash flow, constant cash flow is $100. Discount rate is 10%. C over R is 1000. We assume the first cash flow happened at the end of first period. So we have this. So I'm going to .ice, and I'm going to show the formula again. So this is the formula. This is C over R. Okay. Okay. So let's. Okay. So I simply let's copy paste. Then we print total. See, it's very quick. Total. And total is also 1000. Okay, so we use 500. Okay, people will argue why we use 500 and not use 50 or 1000, because there's an issue here. Okay, there's an issue here. We might cut off too early. Suppose the C is very high number. So let's use another called while loop. Here. Okay, total equals 0, CR is 10%. Suppose while, so we have your while loop, okay. And suppose we define tiny. We define tiny. And so tiny, it's a small value. It's small value. Suppose it's 1 cent. Okay, it's 1 cent if present value is larger than tiny. Then we are going continue. Okay, otherwise we will stop. Okay, and so let's use I equals 1. Okay, total, so present value equals, and we use the exact same thing. Okay, this is paste. Okay, I repeat the concept here. Okay, and same thing as before, we have input. Okay, let's remove this part and put it down here. We have the cash inflow. Sorry, we have the parameters. So constant cash flow is 100, discounted 10% with tiny. The tiny we use a control. It's a control value. Okay. If our present value is less than 1 cent, we stop. Okay. So this is total, and I equals 1. Okay. So we calculate the present value first. Okay. So obviously, so let's calculate, this should be larger than 1 cent. Okay, so if we do this one, so present value, we calculated already, so it's $90.91. Okay, then we are going to calculate this one. Okay, total equal to this one. And one more thing is we have to add incremental value. Okay, we add incremental value. Okay. I repeat the concept logic here. Okay, we have a small value. It's called tiny. It's 1 cent. Okay, so if the present value is higher than 1 cent, we continue. If present value of our new calculation is less than 1 cent, we stop. Okay, for if we use these conditions, then we don't have to worry whether we cut off too early. Now we can look at I when we cut off how many round of loops. Okay, so total, you see, this is 999.9. So let's look at the present value. So this is less than 1 cent. Okay, so this is total, and how many? We only need 98 rounds. Instead, remember the previous one is 5,500 or 500. So let's increase this I. Suppose tiny we add one more 0. Okay, so let's run it again. See, so we assign total equal to 0. Okay, so let's do it. Okay, so total, you see, it's very, very close to 1,000. I only 122. Okay. For this one, I mentioned it before, we can use repeat. We can use repeat. Okay, so let's do it. Okay. Let's copy this part. Then we can use repeat. So basic idea is we always run this part. We always run this part. Okay. However, we need a condition. If present value is less than tiny, then break. So this is our condition. Okay. So this is our condition. Okay. Then we don't need to calculate the first one. Okay, so we have constant cash flow, we have discount rate, we have some tiny value, total equals 0. So this is present value of perpetuity, and we have initial value. Then we repeat. We calculate the present value, we add to total. So we add to the old total. So this is on the left hand side is new total, on the right hand side this is old total. Then we increase I by 1 step. So if PV, we calculate the PV here, is less than tiny, we stop, we break. Okay, so let's run this one. Okay, so this is the total, and so let's look at I. I is 122 round. We run 122 round. Suppose it's end of case period. Okay, the first cash flow. So if the first cash flow happens at the end of K period, okay, then we have the following formula. Present value perpetuity equals C over R and times 1 plus R with power will be K minus 1. So this is the formula. Okay, I repeat the concept. Okay, and the present value of perpetuity equals C over R, and we have 4 conditions. So number 4 is first cash flow happen at the end of first period. Okay, so if it is not, okay, if it is not, okay, I have to divide by, sorry, this is divided by 1 plus R raised to the power of n. If you see the K equals 1, so this is 0, this vanished. Okay, and in the, okay, so C equals 100 and R equals 10%. Suppose K equals 7. Okay, K equals 7. Okay, then we can calculate C over R. Okay, C over R, C over R. So let's call it A. So this is like A, the present value function. So this is A, and R is 10%. That's my case 7. So actually it is 7 minus 1. Okay, so this is, remember, the C over R is 1000. C over R is 1000. If happened at the end of first period, if happened at the end of 6th period, okay, sorry, 7th period, so we discount by 6th period, K minus 1. So we have this number, okay. So if we have this formula, then we can easily, so we simply change to 7, okay. Then we can copy paste. Okay, total. So this is based on formula. So this is based on our loops. Topic number 2, how to use different loops to price present value of annuity. So actually, after we understand how to use loop to price present value perpetuity, and it's much easier to understand how to use loop to price present value of annuity. So let's look at the definition of annuity. .ice in class exercise. So this is present value annuity is 16. So this is 16. Okay, so definition of annuity, we have 3 conditions. It's quite similar, so they are quite similar to the present value perpetuity or perpetuity. The same cash flow at the same interval for perpetuity forever. This is for n period. Okay, so example number 1, the first cash flow at 3 for n period. So this is last period. Okay, example number 2. So this is a special case. The first cash flow at end of first period and last for n period. Okay, so this is last period. So this is a general one. So it's K. Okay, if K equals 1, then example 3 will collapse to example number 2. Okay, if K equals 3, then example 3 will become example number 1. Okay. So this is a general formula. Okay, its k can be any number, can be 5, can be 20, can also be 1. However, if k equals 1, then we have this general formula. Okay, so the general closed form solution will be C over R 1 minus 1 divided by 1 plus R powers n. So this is a function. Actually, in chapter 2. In chapter 2, we discussed this function. And similarly, we can use loop. We can use loop to calculate. Okay. In terms of coding, I think it's trivial. For example, here, so let's call n from 1 to 10. Suppose this is 1 to 10. The only thing we just remove, we call n. Okay. So total equals 0, and C is 100. R is 10%. We have 10 period. Okay, with 10 period, start from 1 to 10, and I in n. We calculate PV. We add PV. Okay, so let's copy and paste. Our PV function, we have to activate this one. Okay, so this is total. The total is 1616. So let's write present value annuity function. Okay, so this is present value annuity. Okay, so this is CRN. So this is C over R times 1 minus 1 over. So this is a simple one line. So let's 1, 2, 3, 4. Okay, so this is present value annuity. C, constant cash flow, R, and K. C over R. Okay. So let's copy and paste. So let's test it. Okay. The present value annuity. So this is 100. And 10% for 10. Okay. We have identical result. Okay. For this formula, it is, we assume, okay, so this is present value of annuity, same cash flow, happened at the end of same period, and first cash flow happened at the end of first period. We can easily extend this formula to the first cash flow happened at the end of any case period. Okay, and for our loops, okay, it's much easier. Okay, for example, this is from 7 to 16. Okay, we have 10, so we have 16 minus 7 plus 1. So this is equal 10. We have 10 period. And the first cash flow start at the end of 7th period. We can easily modify this one. So let's calculate. So this is total. Okay. And for this one, we discount by 6 period. Okay, so let's copy paste this value. So this is 10 period. So let's call it A. So A times present value F1. So this is, we discount this one, A, by, because 6 period, 7 minus 1. Then we have the same result. You see, we can use a loop, and we start n from 7 to 16. Alternatively, we apply this formula, and then we discount by 6 period. We have the same result. Topic number 3, NPV function. .crs.ice. So this is NPV function. 17. The definition of NPV is simply the present value of all the benefit minus present value of all the costs. Okay. So if we define cash outflow is negative, cash inflow is positive, then NPV is present value of all the cash flow. Okay. So NPV rule, so if NPV of a project is positive, we accept the project. Otherwise, we reject. Okay. I'm going to show you Excel function and confirm. Excel function NPV actually is a Pv function. Okay, I'm going to copy. So let's launch Excel. And this is our data. Okay, so I'm going to use data and text to column, and I use comma. Okay, simply separate it. Okay, so this is time period is we can call it T. So this is cash flow. Okay, we just use choose a discount rate. Suppose we use 10%. Okay, so this is 10%. Make it bigger. And I repeat, at time 0, we invest $100, and at time period 1, end of the first period, we receive $20, end of second period, $30. So what is NPV? So what is NPV? Okay. And I'm going to use two methods to calculate. The first method, we apply the Pv function. The second method, we apply the NPV function. Okay, so we calculate present value. Okay, so equal present value. Okay, so this is rate. So this is 10%. Because I'm going to fix it, I hit F4. So $F $S1. Okay, so along the period it's 0. Okay, payment is 0. So I use comma, and future value is 100. So we are going to get 100. Okay. Remove the dollar signs. Format cell, I use number and two decimal places. Okay. For the Excel, if we enter negative value, we get a positive value. Because if the future value is negative, we get a positive present value. Okay. Okay, I copy and paste. And so this is total. Okay, so this is total. Total is simply the summation. Okay, summation. Okay, it's so actually it should be positive. Okay, it's positive, and because of the Excel sign convention. Okay, this is first method. The second method we use NPV function. Okay, so this is NPV. Okay. NPV, we have rate, then we have all the values. Okay, the rate, same thing, is 10%, comma. Because NPV actually is Pv function. Okay, we have to start from the first period. Okay, we start from first period, we close it, then we add back initial, sorry, this one. Okay, I'll repeat. Okay, I should put here. So this is NPV, and our rate is 10%. Because NPV is Pv function, we have to start from first cash flow. Then we add back initial investment. Then we have the, I'm going to use this called formula. So this is a true NPV, and I'm going to use formula. Okay, I repeat the concept here. Okay, we calculate the NPV. We have 1, 2, 3, 4. We have 5. We have 6 cash flow. $100 today, cash outflow. Then 20, 30, 40, 50, 20 in the future, cash inflow. Okay, our NPV is 19.6 if we use NPV function. Again, NPV function, Excel NPV function only apply to the future value because the initial $100 is present value. We have to add it back. So this is how to calculate NPV by using Excel. Okay, so let's go back to R. Now let's look at how to write a NPV function in R. Okay. Again, we are going to use this data set. So copy, and I'm going to copy this one. Okay, so this is our data. So we can use x equal rate CSV and clipboard. Okay, and suppose we have to. I'm going to do this one first because I have to copy paste, and I'm going to copy this number. Then X. Okay, so I copy. This is copy CSV and header equals false. Okay, so this is header. Obviously, so this is our payment. Okay, the cash flow. Okay. And for the NPV, since we have the Pv function. Okay, so this is present value of one cash flow. Okay, we can use cash flow. So cash flow equals X, so cash flow X $2. So this is our cash flow. So this is our cash flow, and also we can use our time period. Okay, so this is time period. Time period is simply $V1. Okay, we can use this one. And we start from 0, 1, 2, 3, 4. Okay, now we can write. So this is I in period. So this is I in period. Okay. Then we can use total again. Total equals 0. Okay. Actually, the total is NPV, right? Present value equal. So we can write down. Okay. So what is future value? So future value will be cash flow and I. So this is cash flow I. And what is N? So N will be and period I. And present value will be present value function. Okay, so this future value and R. Okay, R is constant. Okay, and total equals total plus present value. Okay, and we have R equals 10%. Just assume 10%. Okay, I repeat the logic here. Okay, and so we have this function, present value function, for one future cash flow, and we will record this one many times. Okay, and discount rate is 10%, and assume we just copy paste, use the read.csv. If you use Mac, then is pipe. I'm going to show you the corresponding MAC command line. Okay, we have, so V1 is time period, V2 is cash flow. Okay, cash flow, then we simply copy and paste. And for this one, I in period. Okay, okay, no. If we use N, so this is N equals mass and period. Okay, so this is I in 1 to N. Okay, 1 to N. Okay, obviously N should be 6, so let's copy paste to see how many N. So N is 6. Okay, and for the first cash flow is future value, and the first time period is N, present value equals present value function, future value in R, R is constant, total. Okay, then we can copy and paste. Okay, total. Okay, 39.647. It's different. Well, we have a wrong output because you see we have N here and also we have N. Okay, so I'm going to use N0 and from N0. Okay, so N0 will be total number period. So this is N we retrieve from this period. Okay, so let's do it again. Good. Then we have the same result compared with Excel. Okay, and based on this one, we can write two functions. Okay, so let's look at the NPV function. How can we write NPV function? We can have several ways. Okay, so this is NPV function. And cash flow and period. And also we have the input R. Okay, so this is cash flow, input, then return. Total. So this is we can generate NPV function. Okay, the condition is we have, so this is vector, this is another vector. Now we input R. Okay, so let's look at this one. However, we have to 0. Okay, N0 equals length cash flow. And so let's use N1 and 2. N1 and 2. So this is length and period. Okay, if N1 equals N2, then we have our output. Okay, so this is our output. Else, then we print error message. Okay. Else, and cat, we print error message. Okay, dimension are not equal. Okay. Dimension are not equal. Okay, make it big. Okay. originally we only have this part. Okay, if we want to write an NPV function, so this is one type of NPV function. We have vector of cash flow, we have vector of period, and we have R. Okay, then we assign total equals 0. So usually I put total here. Okay, I put total here. Then it's conceptually it's more clear. And for this one, make sure they have equal dimension. For example, 1 by 10, 1 by 10, 1 by 5, 1 by 5. Okay, we can use if stop, okay, instead of if else. Okay, and present value. So this is NPV function. Okay, the first one is cash flow. The second one is period, and 10%. Then we have our result. Okay, so this is topic number 3, how to write NPV function. Of course, we can mimic Excel NPV function as well. Topic number 4, and calculate IRR. Okay. We have the NPV function. Okay, I forgot to mention should be N1. So we have NPV function. Okay, I'm going to copy and paste here. Okay. If we have some value of vector, okay, then we can calculate NPV. Okay, so let's ICE. Okay, dot ICE 18 is IRR. Okay, so ICE IRR. And so if we have NPV function, okay, so this is X. So this is cash flow, and X time period. Suppose we have 10%, and we have some values. Okay, and so let's discuss the IRR concept of IRR. Okay, so this is 18. So this is 18. So IRR is defined as discount rate makes project NPV equals 0. Okay, and this is our logic. Okay, so this is our logic. I'm going to remove this one. Okay, so this is our logic. And I'm going to have logic. Okay, and suppose we run 5,000 different R. Okay, we have different R, and then we calculate the NPV. We calculate, so we have 5,000 NPV. Okay, so we choose smallest. So we use absolute value. NPV is smallest, and that R will be IRR. So this is logic. Okay, and we choose 5,000 discount rate. We calculate 5,000 NPV. The absolute value, the discount rate corresponding to the smallest NPV will be our. Okay, suppose so let's call NPV old. Okay, I'm going to sign a very big number. Okay, and we are going to have, and for example, we have I in 1 to 5,000. Okay, we have 5,000 loop. Okay, we have 5,000 loop. Okay, and so we have discount rate. Discount rate, we can use I times a tiny value, for example, 0.001. Okay, suppose we are going, for example, I equals 1 is 0.001, I equals 2 is 0.002, and continue this. Okay, then we calculate NPV. So this is NPV we call the new. Okay, so when NPV we call NPV function. Okay, so this is cash flow, and this is period, and this is discount rate. Okay. So if our NPV absolute NPV, I'm going to use absolute here. So this is to make it. So this is absolute value. Okay, I'm going to calculate absolute value. Okay. So when the NPV new is less than NPV old, okay, and we find a small value. Okay, so basic idea is we find a small value, then we do two things. Okay, so let's call it IRR. Let's just use -9. Okay, so if we found a small value, and then we replace old IRR with new one. So this is new one. Okay. Then we replace NPV old with NPV new. Okay. Then we print IRR. This is our solution. Okay. So this is the logic. The logic is we have many different discount rate. We calculate 5,000 NPV. Okay. We calculate 5,000 net present value. Okay. Then the R corresponding to smallest NPV will be our solution. Okay. And for this one, we generate a small value and we increase a little bit every time. Okay. And then we calculate NPV, cash flow period R. So if absolute value of new NPV is less than NPV old, and then we replace R with our new solutions. Then we replace old with new, and then we continue this process until we find the solution. Okay. Okay. So we are going to cash flow and period. Okay. And so this is our cash flow. Okay. And from our, so let's try this way. Okay. Let's go on top. Okay, for this way, we can get our data set. Okay, so if you use Windows, I copy paste this one. If you use the Mac, you use pipe Pv paste. Okay, I use this one, and then I copy, highlight, and copy. Then I record the previous command. I delete the number signs. Okay, so this is obviously, and this is not data set. So I have to use header equals true. And so I have my data set, right? So the first one is cash flow equals X $, cash flow. Okay, so this is cash flow equal X $ cash flow, and the period equals X $, and time. Okay. Finally, I can just copy. Okay, I forgot. I have some negative signs. Okay, so this is so let's copy paste around it. Okay. So finally print IRR. Then we have the same result. Okay. I repeat the logic here. Okay. The logic is, and we have 5,000 different discount rate. We calculate 5,000 NPV. Okay. And so the discount rate makes absolute value NPV smallest will be our IRR. And so we generate a big number, okay, big number, and we just, we define IR as missing value. We can use NA, it's not deal here. And we increase the R a little bit, okay, and actually we can just, if we want to increase the, make the more decimal places, okay, then we can just increase this one, okay. And we calculate NPV new, we use absolute value, then we compare our NPV with old one. If it's smaller than the old one, then the discount rate will be our new internal rate of return. Then we replace this one. Okay. Then we can simply copy and paste. And because we have like 500,000, okay, then we can type IRR. Then it will have more decimal places, more accurate. Obviously, we can make this one a function. Another function we are going to use is called, I'm going to use this one. Another function we call is called read.fwf. Okay, so this is fixed width file. Okay, so let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, suppose we have this kind of input. Okay, and so still we can use x equals read fwf. So this is clipboard. From clipboard, and suppose we want 3, 4, 2. Okay, so we have 3, then we have 4, because in total we have 1, 2, 3, 4, 5, 9, 10, we have 11. Okay, 3, 4, 7, 8, 9. So let's use 1, 1. Okay, and so we are going to, so let's try it. Okay, okay, and we highlight these 2 lines, and then we go back to our, so let's look at X. Okay, and so this is our output. Okay, so let's go back here, and we are going to compare. Okay, and so these 3 indicate we treat first 3 as our first variable. Okay, 4 and this 4. Okay, so 1, 2, 3, then we have 4. We have another 2, 8, 9, and then we have 1, and the last one is 0. Okay, so this is our input value. Our input value crucially depends on the width. So this is, we call this width. Okay, and suppose we change it. So we want skip. So this is 4. So instead of 1, 2, 3, we want skip 4 variables. So we are going to see 1, 2, 3, 9, 1, 0. Okay, and so this 4 will vanish. Okay, so let's go back. Okay, and so we suppose we skip 4. Okay, then we have negative value. Okay, oh, I have to copy this one first. Okay, copy and skip. Okay, I'm going to copy back this one to our notepad. Okay, and if you count the position, first 3, 1, 2, 3, the next 4, we skip next 4, then we count 2, 1, 0. Okay, so this is a basic structure of this read FWF. Okay, read.fwf. I'm going to use this function to get the data from SEC quarterly index text file. Topic number 5. So let's look at how to parse one SEC quarterly index. Okay. So type .ice. Before discuss this function, okay, I'm going to use 2 functions. One is called paste, another is called paste 0. Okay. So this is 19. And for example, I have two phrases. I love dogs. Okay. If I put them together, I can use paste. So let's come here. Okay. So if I want to use a separate, so SEP, and I use a comma, then I add a comma between. If I don't want anything, then I use this one. Separate. SEP equals double quotation and double quotation. Nothing between. A pair of double quotation. Alternatively, we can use paste 0. Okay, paste 0. Then we just, we have nothing between. So paste 0. 0 simply means nothing between two strings. Okay. Okay, so let's look at, so we can SEC find quarterly index. Okay, quarterly index. And I'm going to randomly pick 2020 and Q4. And so this is complete IDX. Okay, actually is a text file. Okay, so I'm going to download it. We can click download it. Okay, I'm going to copy this line, and I'm going to use Notepad. Okay, so let's so this is file I just copied. So I know it's IDX. So this is, so let's call it parse. Okay, so let's call infile. Infile. So this is complete dot IDX. Okay, so infile. Let's make it small. Okay, so this is infile HTTPS. So this is 2020 quarterly 4 complete IDX. Okay, and we can just test it to see whether this is correct. We can download. So just paste here again. Okay. Yes, okay, we can download. Okay, so this indicate is correct one. Okay, so this is output, and output. Oh, so let's read. Let's read A equal read my file 100. Okay, so let's only read 100. Okay. Okay, so this is in file. This is in file, and we simply use read line. Let's read 100 line. Okay, let's copy and paste to R, and I treat this is our first step. Okay. Read. I have extra L. Okay. So this is head. Okay. So this is our. It's bigger. And stop. Okay. And obviously, if we use head A, we can see we have 10. We should skip 10. Okay, the first observation, the first issue is we should skip 10. Okay, the second observation, you see we have complete name up to here. Then we have form, the second level form. then we have CIK, then we have a date, and we have, actually this should be location. So this is location. Okay, I repeat. Okay. And we use in file, we pick up specific company ID. Okay. Suppose instead of, so I'm use 19, so 2019, and we use Q1. Okay. Suppose instead of 2020 Q4, we use 2019 Q1. Okay. Then we issue A again. Okay. Then head A20. Okay. You see, this is 2019. This is first quarter because I use first quarter. Okay, 2019. Okay. That's step 1, and we make sure our in file is correct, and we can just retrieve 100 line. Okay. So this is I call first step. Okay. And obviously we can save it. We can save write and A. We can make very simple A and a file equals and t.txt. Okay, we save as a text file. Okay, and we can open later. Okay, I'm going to guess the first 100 line from this specific index file. I'm going to use 1919 Q1. Again, read the line. We're going to get 100 observation. Okay, 100 observation and head A 20. Okay, so we know that this is header. If we want to retrieve this data set, we should skip 10. Okay, so next one we want, because we are going to use read.fwf, we should know our width. So what is name? How many characters long for the name? What is the form? What is CIK? And obvious CIK is 1, 2, 3, 4, 5, 6, 7. Okay, and date is 10, right? 1, 2, 4, 5, 10 is 10. So it's 10 character long, and the rest will be location. Okay. In the future video, I'll explain the usage of this one. Okay, up to now, I generate a function called a ruler. Okay, if you are taking my course right now, you can just type .ruler, ruler. You are not taking my course right now, you can type source http data yyyy.com and code r ruler.txt. Okay, remember we have used head and we use 20. Okay, we are going to have a ruler. For example, we choose 3. We choose 3. We want the location. Okay, so this is A 11, 12, 13. So simply type ruler A and 11 to 13, then close it. Okay. So this is I call the ruler. Okay, simply put this 3 line, and there's some, so we can count. Okay, and obviously for the name. Okay, so this is 60, 61, and 62. The first one W equal C, and first one is 62. Okay, so 62. The second one is, should it be 70? So let's use 74. And then 86. 86. Then 39. The last one is 141. Okay, so this is new one. Okay, 1, 2, 3, 4, 5. Okay, corresponding to end of 5 variables. Okay, so let's W2 we call difference. So this is different function. Okay, W2, then we have 12, 12, 13, 42. Okay, and we have to add the first one. Okay, so my width will be C W, the first one. Okay, then W2. Okay, so this is our first. Okay, I'm going to put this one again. Ruler. So this is ruler A 11 to 13. Okay, I put here by WDTS. Okay, so according to read.fwf, we need 5 because we have 5 variables. Okay, so this is 62. We are going to read the name. So next 12, we are going to read the form, and another 12, we are going to read the date filed, and 13, and obviously we should have 10. 1, 2, 3, 4, 10. Okay, so let's try to read this one. Okay, and let's save as t.txt. So this is complete one, this is half. Okay, this is 100 lines. It's much easier to work with a small data set. Okay, so this is only a small one, 100. So this is a big one. Okay, so let's together. Oh, sorry. Download file. Okay, so this is complete one. Okay, we are going to use X read. Okay, so this is t.txt. Okay, we know this is small data set, and the width equals my width. Okay. Okay, so this is our structure. Okay, so X equal read fwf, and t.txt width equals my width. Okay, see, we can easily read. So let's look at X. Okay, so obviously we have to skip 10 equals 10. So let's skip 10. Okay, you see it's quite clear. So we have the name, we have the form, we have the finding date, so CIK, and obviously something must be wrong. Okay, so this is Edgar, E is missing, and the last one. Okay, and so this should be not 13, so let's talk 12. Okay, so so this is 1, 2, 3, 4. So this is number 4. So instead of the 13, we add 12. Okay. However, the summation will be not 1 for 1. Okay. You see, remember, we have 1 for 1. So the last one, we should add 43. So last one will be 43. Okay. So let's retrieve the data again. Okay. Okay, then we have complete, right? We have complete, so Edgar. Okay. However, you see this one, and this is okay, and it looks like we have some extra number here, and this is should be 1, 2, and also 2. Okay, and we can use, okay, so this is this one, okay. Suppose we know 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. So this should be 10, negative 2. Negative 2 is simply we skip 2, okay. So we can use, okay, so let's use C, and we just copy. So 62, 12, 12, and we use 10. Then we skip 2. Then we have 43. Okay. Okay. Here we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. Then we skip 2. Okay. Then let's run this line again. Okay. So let's run this line again. Okay. So let's look at head. Okay. Now it's much better. You see, this is location, and this is our filing date. This is CIK, and I think we can skip another 2 here as well. Okay. And so this is X colon name X, and we add complete. So we add complete, then we add form, and we add CIK, then we date file, then we add location. LOCATI. Okay, so this is name of the company. This is form. We should skip some 0 here. This is CIK, date file, and location. Okay, suppose we just use this one. Okay, so let's read the complete one. Remember, for here we only use T, so let's read the T2. Okay, so let's read T2. Okay, so let's call it Y. So let's call it Y, and we read T2. Okay, because T2 is complete data set. Okay, if we can pass the T2, okay, then we can read it directly from SEC's web page. Okay, and I'm going to show you something. Okay, so there's some error message. Okay. This error message is quite difficult to identify. I try to show you a way to identify. Okay, and so this is 16807. The basic idea is, so let's get this number. Okay, let's look at this line. Okay, suppose we use K. So K equal read line. Okay, read line. And remember, we use big one. Okay, T2, TX2, and we simply read to K. Okay, we know this is line. So basic idea is this line does not have 5 elements, because this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, for the top 100, we see 5 elements. Okay, so let's look at K 16807. Okay, so this is, so let's, oh, I think I skipped, because I skipped 10. Okay, so let's don't skip. Because I skipped 10, I add 10. Okay, I add 10. Okay, so this is line cause the problem. Okay, you see here, we see 1, we see 2, we see 3, and we see 4, we see 5. Okay, and it looks strange. We have the name, we have the form, we have CIK, and we have this one, we have this why this line caused the problem. Okay, so actually the reason is this number signs. Okay, and remember number signs represent comment. Okay, when the program with this one, it will replace everything after number sign as comment. Then it will simply delete everything. Okay, it is simply delete everything. Okay, and so let's confirm this caused the issue. Okay, this one indeed caused the issue. Okay, so you see here, we know we read 100 will not count. Okay, for this one, x read and t.txt, and this will not cause any problem. Okay, and so let's open this one. So this is okay. So get wd. So RP. So this is teaching RPYR, and so this is my file. Okay, so this is my file, and so let's add something here. Okay, so I'm going to add a number sign here. Okay, and so this is 10, 11, 12. Okay, 12 or number 2 because I skipped 10, so this is 2. This one will cause a problem. So let's save it. Okay, so let's run exactly same one. See, error in scan 92 did not have 5 elements. Okay, and again, so let's delete this one. Okay, so let's delete this one. Then problem will solve. Okay, I'm going to show you another issue. You see, then problem solved. Okay, and so let's do it again. Okay, because I put here, and this code only find one element. So let's put it at here. Okay, so let's put here. This will not cause any issue. Why? Because it will treat 1, 2, 3, 4, 5. It will still find 5. Okay, so let's run this one again. You see, it will discard this part. Okay, this part. So number signs is an issue. Okay, the number signs. So let's delete this one. Okay, save it so we can run it correctly. Okay, now we know the number sign will cause the problem. Okay, so how can we solve this issue? Okay, and I have a silly solution. Okay, I'm going to teach you one called the substitute. Okay, and suppose we have a equals, so let's use T1 equals ABC 99. Okay, so we have a phrase called ABC 99. Okay, suppose we want A replaced with D. Okay, so G, so substitute A with K, T1. Okay, so ABC and substitute A with K. So this is our string. Okay, I'm going to this one. Okay, A, B, C, D, A, B, 99. Okay. Okay, we substitute A with K. Okay, then we substitute the first A with K. We keep the second A. Okay, another one called the global substitution. Okay, the global substitution, we substitute alt A with K. You see we have 1A, we have 2A, we substitute both A with K. This is related to the string manipulation. I have one chapter related to simple string manipulation. Okay, so basic idea is I'm going to use number sign. I'm going to use K to replace number signs. Okay. Let's do this one. This is much easier to do. Okay. So let's start from here. Okay. So let's download to. Okay. So this is doesn't matter. Okay. So let's download it. So let's read it and okay, do this way. Okay. We downloaded first. Okay. We downloaded first. So actually we downloaded already. Then we read and t2.txt. Okay. That we downloaded already. Okay, we download and we retrieve it. Okay, so let's try this one. And we downloaded already. Okay, just okay, we download the data. Then we simply retrieve the same data. Okay, then we replace it. Then we save it. So this is much faster. Okay. That is done. Okay. And we replace this one. Okay. Then we can get our command. Okay. So actually we can use .x and weight, fixed width, and so this is index 2019 Q1, my width skip equals 10. And so actually we download the quarter index file, then we retrieve it and we replace number signs. You see, problem solved. Okay. Then we use head.x. Okay. Then we have add column names .x c company. Or you can use name, company name. See, company form, and so this is CIK. CIK is simply central index key. Is company ID. Okay. Date file. So last one will be location. Okay. So this is location. So this is .x and tail x. Okay. And you see the company name, and CI. This is form, and this is CIK. This date file, and the last one is location. Okay. In total, we have 200. We close. We have 297,000 files. Okay. Then we can save it. Okay. Save .x file. Remember, this is index 2019 Q1.rba. Okay, sorry, save. Okay, for this one, and you can use another name. Remember, when we download all the zip file, and we can use this is better. Okay, and for this one, we can retrieve it. Then we can automatically have the name of the company. We have form, we have CIK, we have date. Okay. For example, if we want how many unique form, okay, we can use form equals unique. Okay, unique. This is .x form. Okay, and we have length form. So total we have 324. Okay, we can type form. So this is all the finding, SEC finding. Okay, and for this is a specific one. So let's look at how many complete file. Okay, exact same concept. Length unique.x, and this is CIK. Okay, in total we have close to 73,000 company file their report to the SEC in the first quarter 2019.